Okay, so I think we can. Let me share my screen. All right, so we were discussing about machine learning models, and we started with a discussion of linear regression. And during the session of Dr. Nitan and ma'am, you might have gone through the backpropagation and gradient descent. So the portion that we had covered till that point of time was we were discussing about gradient descent in linear regression, and the summary of it that we start with one hypothesis algorithm and then with initialized weights, and we try to find out the best fit linear model for the data. So this shows one of the demonstration where it start from some initial value, and the green line shows that how at each iteration uh, tries uh, model tries to come up with the best fit line for the data. So, and we have seen the implementation of it. Though we have not seen the linear regression implementation, we I just introduced sklearn library to you, where sklearn can be used to write code for machine learning models. And we discuss various modules available in sklearn, like sklearn datasets that contains some of the example datasets, sample dataset that you can use for learning purpose, and all those classification regression models are available in sklearn, and various models have different uh, working and approach or algorithm for training, and based on that you the models are categorized into different modules, like a linear regression and logistic regressions are linear models, so that for that you have uh, a library which is a module called linear model inside sklearn. And for tree base you have a tree model, uh, and other categories of modules in the sklearn. So we towards the end we discussed ki, okay, so whatever the model that you want to apply. So before that, this node this code I have shown you to how to load our sample data and how to perform the train test split. Then we discussed about the so let me rerun that code so that next. Okay, so when we run it, it loads the data set, and after performing train test split, you get training data and testing data, and we are just printing the shape of it. So if you see here, X shape, training shape is 120, and dimension is 4. So you have 4 features in it, and testing also contains the same number of features, but test data contain instances are 30. So because the test size we have mentioned 0.2, it is splitting the whole data into two parts: training 80% and 20 testing purpose, testing data. And the random state is basically to control the seed randomness of the function, that which instances are going into the 80% and 20% in the whole data. So the random to control the randomness, so that every time when we run the code we get the exact same results, we provide the some random state. So there are three main uh, functions in it. One is fit, predict. These are the two main functions in any model, whether it is a decision tree, whether it is you are training a neural network or any other model. You call the fit function on training data, and you make prediction using predict function, and you pass the test data. So this was the last discussion we had from sklearn library, which have a module called linear model. We import the logistic regression class, and this linear model have other models as well. So that's why we, instead of writing import logistic regression, we are writing from. So that means that from this module we just importing logistic regression, and to check the performance of the model we are importing the accuracy score function. And that's where it start three uh, main line of code. One is the creating an instance of the model by calling the constructor. So right hand side it's a constructor, and constructor of any other model, machine learning model, takes some hyperparameters you can pass. Even if you're not passing anything, that will be initialized with initial values or default values. So logistic regression, if you click on it, you will see here all the different uh, parameters that you can set. So solver, random state, maximum iteration, multi-class. There are different attributes that you can give. If you're not providing any attributes or parameters, then this this will use default. For example, maximum iteration, if you are not providing, it will take 100, and intercept scaling 1, and value of C penalty L2. So that will be taken as default value. And so you initialize, uh, instantiate an object of that model, and using the instance variable, you call the fit function, you pass the training data that we had gathered in the previous step. And once the model is trained, so this line of code will train the model. And once the model is trained, the trained model can be referred by the same variable name, and you can call the predict function. And to predict, you pass only x data, only x, not y. So you get some prediction, and those prediction, let's say we are calling it y prediction, and then based on actual y test, the actual data was we had in testing, and the prediction, we calculate the accuracy score by calling the function accuracy score. There are other functions are also there, performance matrices. Right now here we have imported only accuracy for precision recall. For other performance matrices, or even you want to uh, calculate all the performance matrices at once, you have a classification report as well that we are going to see. If you run this model, you get the output. So model is trained since data was small. If you have a large data, then it will take some time, and then it prints the performance matrices. So a simple three-step process: instantiate a model, call the fit function, and then evaluate the model. Simple on test data. Another classifier is decision tree, which comes under the sklearn tree module. Before going to it, let's me uh, okay. So I'll go to decision tree theory part. So I'll, I'll quickly introduce what decision tree. So it is a tree-like structure, and internal nodes basically represent the test on an attribute. So you have different attributes in the data. For example, let's say in a structured data, you have some features. So at internal node, for each feature and the value of those features in the data set, like first data, second data, third data, those data might be a category or numerical value and so on. For example, some numerical value is there for one feature, so that at each decision node, for each feature, uh, test is mentioned. For example, in case of f1 is numerical, so let's say f1 value, so value is less than 100 will go here. We are splitting based on this, and greater than 100 we are splitting based on this. So some test is there on internal node, and branch represent the outcome of the test. For example, 100 instances थे, and there are 100 instances, and for example, let's say 50 instances was having less than 100 value for f1. So 50 instance classified this side, and the rest 50 decide classified on this side. And further, on those 50 instances, we pick any other attribute, for example f2, and we make decisions and so on. Once we uh, elaborate the tree on all or most of the attributes, that model is learned. Now, and towards the end, the leaf node is basically your decision. For example, your output is y is equal to 0 or 1, or maybe two classes. That 0 represents something, let's say fake, or 1 is real, or spam or non-spam, something like this. So leaf node represent the uh, outcome, whether it is 0, 1, or any other outcome. So how decision tree works? So at each, so there are two things. One is what should be the test criteria that you decide, and let's say if you have n number of features, f1, f2, f3, f4, which features first you will choose to make an attribute, make a test attribute or test feature. So it could be there ki f1, we can start from f1, and then afterwards for the child node we can take f2 and so on, or we can pick f2 as a first attribute for selection, and then we can move ahead. So which attribute we are going to select, uh, it is based on some concepts like entropy or Gini index, or any other. So we select the best attribute using attribute selection measure to split the records or instances, and we make that attribute a decision node and break the dataset into smaller subsets, and then start tree building by repeating this process. So again, from the remaining attributes we pick the best one, and the definition of best one is based on the information that it contains. So, and we stop when there are no more remaining attributes are there, and all tuples belongs to the same attribute level, and there are no more instances are there. So if any of one of these condition is met, we stop. So for example, let's say uh, there are two attribute, new recipient and email length. We pick email length as one attribute, and we decide कि, okay, so the value of spam and non spam depends on if email length is less than 1.8, then it is a spam, and email is greater than or equal to 1.8, then it is a ham or non spam. Similarly, after this, you can further use other attribute also. You can use the same attribute again as well, until unless you have exhausted all the instances or basically all the attributes. So this is how tree grows, and that classifies the data into smaller subset until the leaf node have ideally zero error. So that tree represent, for example, email. If email length is less than 1.8 and new recipient is less than 3, then your particular email is spam. And similarly for other, you can just uh, reason through the decision tree what will be the output. And I'm skipping the mathematical part just because we are focusing on the implementation side. So I'm just giving the intuition how decision tree works. There are there are various methods to select the attribute, which attribute you are going to pick first, and then next, and which is based on entropy or Gini index or gain ratio. So I leave that you to explore. So the classifier decision tree also available in sklearn under the module uh, sklearn.tree, similar to the logistic regression which is available in sklearn.linear model. And you can import the necessary module like decision tree classifier, which is a class we are going to import. And we the remaining part remains the same. You train the model using fit method, and you evaluate the model using predict method on testing data, and you can print the accuracy score to understand how your model, which is trained on training data, is working well on the testing data. And you can compare with performance with the previous model that you have built. So if you see here, from the sklearn.tree module, we are importing decision tree classifier. This remains the same as the previous one. We are instantiating decision tree classifier, and again in the construction we have only provided the random state. But if you click here, that you can see there are various attributes you can mention. For example, criteria, which criteria you are going to use to select the attribute on which you are going to split the data. Here by default it is Gini index, so Gini is written. Splitter is the best, and max depth or yes, these are all the values that you can mention. So you can, and once the model is instantiated, you can call the fit function on training data, and on the test data you can make the prediction for the evaluation purpose. And whatever the prediction that you get, that you are having in the y prediction dt, you measure the performance based on, here in this example we have mentioned accuracy score, and which takes two parameter. Again, accuracy score is a function which is there in the matrix module. So all the performance matrices module is inside, are inside the matrix module. All the models are there in the sklearn, are in the different categories like tree based and linear models and so on. And if you run it, so that will train the model, and we have compared it. If accuracy of decision tree is greater than accuracy of logistic regression, then it is printing this, and if it is less than accuracy of logistic regression, then it is printing, else printing both model have similar performance. So in both the cases you have getting 100% accuracy, because the data set was small, and we are having merely some instances to train, so that's why it is overfitting to one. Now we uh, as we have seen that, okay, so you can call the default constructor to instantiate a particular machine learning model, and then you can call the fit function and the evaluate using predict. However, there are various hyperparameters corresponding to every machine learning models, and you can experiment using different uh, subset of those at hyperparameters and check that on which parameters particular machine learning model is working fine. So for example, if you have 5 machine learning model, you find out okay, so with the default configuration my decision tree is working best. Now you can fine tune your decision tree model to come up with the best hyperparameter, so that your performance of machine learning particular machine learning model is improved. So one of the, for example, in the previous case where we are have seeing the decision tree model, where we have used only random state, which is not a hyperparameter. Apart from that criteria, you can change, instead of Gini, you can mention the entropy, and then you can run the model. So there are various hyperparameters. In case of, let's say, uh, SVM, you have different classifiers like kernel, which kernel you are going to use, and the C parameter. So you can directly provide these values inside the constructor, and you can observe how this change the impact, how these changes impact the model performance. So before going to the implementation of support vector machine, if we just look at how support vector machine works, so support vector machine model try to come up with a linear separator, which might be two-dimensional or more than two-dimensional. It could be a hyperplane to classify the data into two categories. And initially, it takes a set of, let's say, best fit models, and out of this it tried to find out one of the optimal hyperplane which have the maximum margin. So in the support vector machine, support vectors are those data which are close to the boundary of the hyperplane or the line. So for example, for this hyperplane or a line, let's say in case of two dimensional it is a line, these two are the support vectors, and from the support vectors it is identified the maximum margin between the support vectors. So for each support vector, for each hyperplane or each for each line, uh, we the model calculates the maximum margin, and for particular hyperplane which is having the maximum margin is basically your the best fit hyperplane for that particular data. However, with the support vector machine, though it is intuitive to see, it is classifying data into two, linearly classifying data into two categories. Sometimes data might not be linearly separable. So in this case here, you can see this is linearly separable model, and you can have various hyperplane possible. So this could be one, this could be one, and this could be one. So out of this, which one is to be picked is based on the margin concept. However, most of the time there might be possible कि you do not have a data which is linearly separable, or the data set that you are using, or data or the problem data that you are using, you might not, the data might not be linearly separable. So for example, this data which have, let's say, x, yeah, this represent cross represent one class, and this dot represent another class. So there is no linear model exists that can classify into two categories. So in that case, if you have non-linear data, then SVM can use kernels. Kernels are basically different functions that handles the non-linearly separable data. So so basically, it what it does, it maps the your original data into higher dimensional space and try to come up with a hyperplane that classifies the data into two categories. So basically, agar if you for intuition purpose, if you see, if assuming this is only two dimensional data x1 and x2, and it is not linearly separable. However, if we add one more dimension, let's say z, and we look it from this side, there might be chance that this data might be linearly separable. So kernels map into higher dimensional space, and it can map up to infinite dimensional space. And this can be used for linearly separating the data into two multiple classes, not linearly, sorry. So you use different kernels. So those kernels are basically functions, so that is called the kernel tricks. So you have various kernels, so you can mention in the hyperparameter. So these hyperparameters basically control the learning process, and it influences how the model learns from the data in its overall complexity. And different parameter values have different impact on the performance. It might be there that your model is working well on one particular set of hyperparameters and performing poor on other set of parameters. So the whole goal of optimal hyperparameter tuning is to find the optimal combination of hyperparameters that yield the best result. So for particularly, for example, let's say dysentery classifier that we have seen in the that we have seen previously. Attribute selection criteria was one of the hyperparameter. Maximum depth of the tree, how much it can go, that is another parameter. So you can mention it and you can play with it with different values. Specifically for support vector machine, you have a kernel. So you have various options like linear kernel, polynomial kernel, and RBF, radial basis function, and sigmoid. The choice of kernel implicitly defines the decision boundary shape, right? So you defines the function that used to map the input data to higher dimension space. And there is another parameter called C, which is a regularization parameter. So normally when you have overfitting in model, so when we say overfitting a model, uh, overfitting means your model is working well on training data. So it has learned training data so well that if we check the model performance on unseen data, it is very poor. Unseen data or test data, the performance is very poor. So overfitting means it learns the training set too well that it overfits to the training set such that it performs purely on the test data. And similarly, underfitting is when model is too simple, both training and test errors are large. So initially, let's say you start with some start the training with some randomly initialized values. During the training, you see training data, the error on the training data reduces at each iteration. For example, in the you might have seen in the neural network in the previous session that during the back propagation, the loss is minimized. So you get a low error. So it moves towards uh, lowering the error as the training happens. In case of decision tree, let's say tree size is increasing and the error is reducing on the training data. Similarly, when we at each iteration when we perform on the test data, the error is also reducing, but after some point of time, there might be chance that okay, so your training error is reducing, but your testing testing error is increasing. That means that you have now the model is overfitted on the training data and it is not performing good on the unseen data. That is called the overfitting. So to avoid the overfitting, you have a regulation parameter called C, which controls the trade-off between achieving a low error and a low error training on data and low testing error, which avoid the overfitting. So ideally, both should be minimized at each iteration. And small c makes the descent boundary smoother, while large C value aims to classify all training examples correctly. These are the two parameters, and you can mention the value. So here in this example of support vector classifier. So in SVM module, now support vector machine can also be used for regression tasks. So you have an implementation called support vector regressor and support vector classifier. So from SVM, you are importing SVC for classification task, and we have imported metric called accuracy score from matrix module. Now we started with first version of the model called uh, SVC. With kernel we are passing linear and C value we are giving 1.0, and we are instantiating the model and we are getting the reference instantiated object in a reference variable, and using the reference variable we are calling the fit function. And once we call the fit function, it trains on the training data. So we are passing x train and y train, and once the model is fit, we make the prediction using predict function on the testing data, and whatever the output prediction that we get based on the difference between the prediction and predicted values and the actual values, uh, we check for the accuracy score. So this is our first model which had uh, kernel linear and c value 1, and we are printing the accuracy. Similarly, we thought, ki, okay, why not experiment with other values of hyperparameters for SVC, support vector classifier. So this time this time we selected kernel RBF and C value 10.0, and we again instantiated the model, and we trained over training data, and we predicted over the evaluated over the testing data, and then we again printed the accuracy score. And next time again, so we come up with two models, and then you can run and test over the models, and we are printing. So currently the both model having accuracy is 1 because the data set was small, but for other data you can compare various models based on different hyperparameters. But sometime you have, uh, if you are manually tuning the hyperparameters by providing the combinations, different combinations, there might be chance that you miss some of the permutation of the hyperparameters, and you might not know the which value is best. For that, what you can do, you can perform the automated hyperparameter tuning using random forest, so using gridsa cv. So now we'll see the example of another model called random forest. We'll use gridsa cv for hyperparameter tuning. For that I have another separate example. I'll show you, that will be the better example for it. Suppose we have, so these are the some of the libraries that we are importing. So NumPy for array manipulation, pandas for reading data, joblib, another library that once your model is trained, you want to save your model. For that you have a joblib library. Similar to joblib, there is a pickle library as well that saves the model, but for deploying in a real world, joblib library is better compared to pickle. And from the dataset module we are importing iris, and dysentery classifier we are taking as our model, which is tree based. And from model selection we are taking train trace split, cross validation score, and k-fold. And metrics we are taking accuracy. And once you want to find out which, so you want to find out the you want to do the hyperparameter tuning, so we are importing grid search cv for finding out the parameters. There is another method called random search cv, so you can pick any one of this. So we are importing those libraries. We load the data that we had seen in the previous code as well. We are loading the data, and we are, from loading the data we are uh, extracting x and y from data and target. Now we want to perform the grid search cv on the attribute, on the hyperparameters, or we want to find out the best hyperparameters. So we have defined a parameter grid. Okay, so what could be the criteria should be for selecting the attributes for splitting the data. So we have Gini, we have entropy. So these two are the, for the criteria max depth we have put some values like 3, 5, 10, or none, and we experiments that which we should be the best maximum depth. And minimum sample split we taken 2, 4, and 10. So at each attribute, how many sample, at least minimum samples are needed to split the data. So these are the criteria on which we have mentioned, and we will use GridStar CV to find out the best combination of it. For example, let's say it might come up with a Guinea 5 and 4 for developing machine learning models. So we have defined a parameter grid, and then our data we have split into training and testing using train test split that we have seen in the previous example. Now what we are doing, we are instead of directly fitting the model, we are performing the grid SAS CV, and we are passing which model we are going to for which model we are going to find out the right parameters. So we have passed the instance of dysentery classifier. See, this is a constructor, so this is an unnamed object basically. Okay, so we are passing an instance of dysentery classifier. We pass the parameter grid on which grid search CV should be performed, and cross validation we took 5, and scoring on which criteria, on which performance matrices it should identify that which parameters are the best. So out of this parameters that we have mentioned, criteria, max depth or minimum sample split, which are the best combination to identify that dysentery model will work best. So we have mentioned in the grid search CV, and once we call it, and on the grid search CV which fit on the training and test training data, once the grid search CV perform the hyperparameter selection, it comes up with the best dysentery model. For example, and we have on the grid search gs attribute gs variable, using the best estimator attribute, get the we can refer to the model that was performing best. So now the out of all the possible combination of dysentery, the best dysentery is we are referring with the best dt, which we get using the best estimator. Actually this targets to the best model that you have achieved. And out of all those combinations, all those parameters that you have mentioned, if you want to see which are the best parameter it had identified, so you can just see the best parameters. So when you print it, so from those combination that we have mentioned, the criteria Guinea was the best, and max depth value 5 was the best, and the minimum sample split was 2. So this was the best model out of all the models of dysentery by using the hyperparameter tuning. And there are other ways also. So on the best model you can call the fit function. So we have got this best model, and you can train the model on this. So we can call the fit function now on the identified model that we have identified, and you can train your model. So once the model is trained, you can predict or evaluate the model on the testing data. Now you can see it is getting 0.9696% accuracy on the data. There is another library called joblib library. Once you have selected one model to uh, train on the data, and then out of that so from that model you come up with the best hyperparameter tuned model, and now you want to save your model so that in future you can load the model and perform the prediction. Suppose you are building an app, then there is a joblib library is there, and from joblib library you can save any model. So you have to import that module joblib, and using joblib you can call the dump function, and you can pass the model. So currently in this example we had best dt was our best model, and we are saving it as a best dt. pickle. So basically, pickle library and joblib library both serialize your model and save it, and in future you can directly load that model. So now the model has been saved as a bestbit.pickle. If you want to see in the Google Colab, on the folder on the right hand side, if you see, this model is saved, and you can download this model. Basically, it's the binary file of that model that has been trained, and you can use that model anywhere else. Let's say if you are building a web application, you can load that model, you can save it model, and you can create a Flask or REST API over it, and you can pass your data of inferencing using web interface, and that can go there, and then your train model you can call the predict. So this is how you save the model. So in this particular examples, what we have seen how to load a data set, and how to train our model, what are the three basic functions, and what are the hyperparameter tuning is there, and what are the hyperparameters where you mention it in the constructor. Sometime you want to find out by the coding that you want to find out the best parameter combination. So you perform the hyperparameter search using, there are two approaches, grid search CV and the random search CV. Using those two algorithms, you can find out the right set of parameters to train your model, and then once you find out the best model, you can train your data, you can train on your data, and you can download the model and save the model for the future reference. Now, till this point of time, we have seen. Yes, I'll share everything. I'll share this slide just after the session, and you will find out in the canvas, right? I think I'm correct. So okay, so you'll get everything. Yes, so I'll download this copy of this collab notebook, and I will share it to the coordinators. They will upload it on the uh, canvas. So you will get everything on the canvas, even the slide that I'm referring to, and plus this notebook. However, in this example, what we have seen, we have seen a simple examples where we are using sample data set. Now, let's say you have some data set as a CSV file, and you want to train your model on over your own data. So I'll show you one simple example for for training a model on custom data set. So I'll take a minute, and I'll share the slide, share the screen again. No, so the okay, so binary files that you save, you can save it in any format, right? So even you could have saved it using bestdt.joblib. Usually, most of the time you will find out that pickle was the popular library that we used to save the model, but it is basically a binary file. Pick you can save it with any name, dot pickle or dot even joblib or anything, dot model as well. So you will find out one uh, one framework is there, ML flow for ML ops, which says the model in various formats as well. Pickle dot joblib, or also simply the model file. That's it, without any extension. All right, so we'll see another example. So any question else? Okay, fine. So we'll see another example where we are going to load a custom data set instead of using a sample data set. So let me Google Colab. So this is the again we are going to build a model on decision tree. नहीं ये आपका वाला नहीं है, ये मैं अर्का सर से लिया था आपका, मैं पहले ही ले आया था. Okay, sorry. Okay, so we are going to build a model on a diabetes patients. So we have so suppose you have collected patient records, person records uh, on some parameters like glucose value, pressure, skin thickness, insulin, BMI, and so on, and you have a output whether particular person have diabetes or not. I am sharing my screen. Hmm. Right. So we are going to build a model uh, on our custom data set we are that we have in this CSV file. So in Google Colab, if you want to temporarily run on custom data, we can upload the data on here. So let me upload it. For example, we have uploaded this diabetes dataset, which is of CSV file. Now, so here four libraries like pandas. Right now we have not seen the pandas library because we were using sample dataset. So if you want to read CSV files or any other Excel files or any other files in your Python code, then you can use pandas library. So what it does, it reads the data and it creates a matrix like structure known as a data frames. And using data frames, you can on the data frames you can perform various tasks. So data frames basically captures your data. So for that we have import. So we have pandas library. So we have import pandas as PD, and we'll call all the functions using PD dot. Again, we are training a tree based model. So we have imported class called decision tree classifier. We have going to perform train trace split on our data. So we have imported train trace split function from the model split selection module. And instead of this time, instead of just checking the accuracy, we want to check accuracy, precision, recall, F1 score, everything. So we have important classification report function from the matrices. So from tree, we have imported the classifier class, which is decently classifier. From model selection, we have imported train test split to divide our data. And from matrices, we have imported classification report. Let's import all these libraries. So we have imported it. And then next, using pandas library, pandas module, you can read any CSV file. So that have the function called read CSV, and in which you pass the CSV path. Now, since we have uploaded the data set in the session only, we have only so in the current session the path is the same location. If let's say your data set is on other location and you are running this code in your laptop or on any local editor, then you have to provide the path of that data, right? In the Google Colab, you can read the data from the Google Drive as well. So if you connect your Google Drive here, for example, here you can see the sign for the Mount Drive is there. If you click here, so it will connect to Google Drive, and once it is connected, your drive will be shown here. So what you can do, you can just whatever the file that you want to read, see here you can drive. You can see now in the drive you will see all the files in the My Drive. So if you have uploaded the data on the drives as well, you can select that particular file, and for particular file you see three dots are there. Just click on three dots. For example, diabetes.csv, you can see here copy path is there. You can copy the path, and in the function you can just paste the path of the your data. So once it is uh, loaded, now your data is inside the data frame. Once it is there uh, in that as a data frame, you can see data frame, and you can look your data by calling the head function. If you're not passing anything, then it will give you by default 5 samples. So you can see what are the attributes like glucose, blood pressure, skin thickness, insulin, BMI. These are the values, and outcome is 1. So this is your Y. Now in the sample, how to get this file? Okay, so data set is there. uh, so I didn't understand, you are asking for I mean particular CSV file, or you are asking for how to read the data? If CSV file, then this is file we you how to upload this file. Okay, so how to upload this file, so that if you are working on Google Colab, so that if you see there is a folder sign is there. So for the experimental session, current session, if you want to upload CSV file, so you can just click here. You will find out an upload button. Suppose that file is in your laptop, you just click on it, you download it from there. For example, I have other files as well. For example, titanic.csv, I can click it and it will upload in the temporary session. However, this will be available till your collab notebook is running. If you want to permanently link, then you can mount your drive. So if you see here, there is one icon for mount or unmount. So when you click on mount drive, so your Google Drive will be there. So what you can do, you can just upload your file on the Google Drive, and once you mount, your drive will be shown here. So in the drive, My Drive, on, and let's say in My Drive you have created one folder for data set, right? So in the data set you can go to particular file, and once you find out, okay, this is my file, so what you can do, you can just click on the dot, and you just copy the path, and you mention there, paste there in the read CSV function, and it will read the data from drive as well. And if you have loaded here, for example, here I have loaded Titanic dataset, and if I copy the path, and if I just paste it here, and if I run it, now that have Titanic dataset. So let's go back to the same example. So we have read the diabetes data, and to just see how the data is there, how to what data contains. So you can call the head function. By default it prints the 5 instance, 5 rows. If you want to print more rows, then you can mention it there, so that will print more number of data. So that actually you are just checking what the data has. What is your output? So output is 10101. One means diabetes is there, and 0 is diabetes, no diabetes. So we got the data. So our first task is complete. Using pandas library, we have loaded the data. And now and you can also, so though we can see here we have these many columns. If you want to get the columns from data frames, you have df dot columns. So once you see here, you can see all the columns are there. But for training a model, we need x and y separately. So from this data frame, we'll have to extract the x and y. In sample data set, it was there as an data in target, but this is a custom data set, so we'll extract x and y differently. So what we have done, from the df, we selected only those columns which are mentioned here in the features, right? And we have assigned it to x. You can see here in this columns I have omitted outcome. And outcome column we have assigned to y, because this was the y. So we have segregated x and y. So when we click it, when we run it, it has segregated x and y. Now we have x and y separately. Now what we can do, we can divide our data into two parts: testing and training. So for that you have train trace split function. Again, that we have seen multiple times in model selection library, model selection module, that takes x and y. Test size you can mention, let's say we are mentioning 0.3, which is 70% out of those instances for training and testing. You could have also checked here df dot shape. So you can see here df dot shape. So you have 768 rows and 9 columns, including your outcome. So you have total number of instances 768. There are some other functions as well, like df dot info. So if print the info, so they print every details about the data. For example, this column, there are 768 non-null values. Let's say if you have 10,000 data of 10,000 entries, some of the values might be null and missing. So that information shows the type of data of the column, and if you have any null values or missing values are there. Though there is no missing values, so we are totally fine. If there are missing values, then we have to uh, perform additional steps to either omit those at those rows that have missing values, or fill those missing values with some appropriate values, which might be average of average values, or any other default values that we want to put. So we have performed the 10 test split. We have divided into training and testing, 30% for testing and 70% for training. And once we divide it, again there is a 3 task: create an instance using a constructor. You create the instance variable, you instantiated the model. You can see here clf is basically your classifier, and using clf variable, you call the fit function, you pass the training data which you get from train test split. You Once you call the fit function, the model will be trained, and once it is trained, you can call the predict to evaluate the model. So that will give you y predicted. See, there is a difference when you are training the model. specifically supervised learning model, you give x and y both, but when you are evaluating the model, you only give the data, not the class or label. Why? Because you want to see how a model is working on the data if we do not provide class. So it will predict, so these are classes or this is the output. And now since you have y test, you can compare, and you can check the performance. So here this time we have used function classification report, and in the classification report we have provided y test, and y predicted the the value that the model has predicted. And once you print the classification report, you will see for zero class, the precision value is 0.82. So it is uh, and okay, one second. Hmm. And recall is 0.778, and the weighted average is this. So your accuracy is 0.73. So this is the whole classification report that you get. If you want to print, this is a snapshot of printing that model that will, okay, so I have to install this library. Okay, so leave it, we're not going into that. So this is about loading a custom data set. So in summary, what we have seen, how we can load our custom data and how we can train over it. I'll show you one more example there. Let me again stop sharing and so meanwhile, if you have any question, you can write it on the chat. Okay, so I don't know that file is. I could not. I find out the file. So what? Let's change this. Oh, somebody is saying something. Okay, fine. So let's see another example for another data. Let's upload this another data. Mhm. Okay. All right. Meanwhile, uh, we have. Meanwhile, I am finding out. I'll let me show you some more examples. You might have. You might have seen. Okay, resume it. Okay. So you might have seen various LLMs that you that are trained. Though we are not going to discuss about how transformer works and how those models were trained, but assuming, let's say, you want to use those models in your task, so how it is how other frameworks and other places or other companies are providing you those APIs into your Python code and how you can use it. So what I'll do, I'll show you one of the simple uh, example of loading a LLM in Python. So there is lab one company, if you have uh, know about Hugging Face. So Hugging Face is the place from where you can uh, import any large model in the Python notebook, pre-trained models, and you can use it. So I'll show you a small demonstration how to load LLM. So you have different large language models like uh, GPT based, uh, GPT Llama based, DeepSeek. You have different models, and if you want to load it in your work, you can load it within 3 line of code. So one is so there are two types of models. One is that works with the images, the vision based, or one with the work with the languages. So all those LLMs are available into transformer module that provide by the Hugging Face. So all those models that GPT models that Chat GPT is using are inside the transformer, and accelerator is to just to use just to accelerate the training. So it has installed this library, and each LLM is basically what it does. It initially it performs some basic pre-processing of the text data. So it has its own tokenizer as well. So to when, unlike any computer model, computer vision model, image model, once you load it, for LLMs, what you have to do, you have to load the tokenizer as well, not only the model. So here you can see, from transformer module we are importing tokenizer, which will use to tokenize the input. And there is another class auto module for causal LM. Using this we can import various uh, LLMs. So here in this example, using the auto tokenizer class, you are importing a Quen model. So there are various LLM models. One of the models is Quen, which is built by the Alibaba. It is 5 billion parameters. So you are importing the tokenizer and the model as well. So model from the auto model for casual LM, from pre-trained. So pre-trained model you are using. You're not training any LLM. We do not have resources. You can use those LLMs. So from those two lines of code, we are loading the tokenizer and the model. And once it is loaded, so see, it has loaded the tokenizer and the model. Once it is loaded, you can use it. That's it. So I'll show you. So though this was not part of today's session, I thought ki I'll talk this about in the later session. But just to give you idea how easy is to load any model from Hugging Face, and you can use. So it will take. Okay, so model is loaded, and now simply for any LLM, what you do, you write a query in terms of, so you call it prompt. So see here, we are giving a prompt. Write a short poem about AI in nature, and we are giving the prompt to the tokenizer. So for tokenizer will create the tokens. So that created tokens is created, and that input, tokenized input, will pass to the model. So the model that we have loaded, we are calling the generate function. We are passing the input, and maximum new token that we want to generate 100. Temperature and top K and top P are the parameters that even the GPT you can set. So this can only happen while using Colab. No, in the Jupyter as well you can import. In Jupyter also you can import. Even in the Python file you can import. Once transformer is installed in your library, then you can import it. So once just you click it, it will generate uh, output. So that you're passing to output, and the output has stored in the output variable. And just when you uh, print, so output is basically you will get a list of outputs, probable outputs. You are printing one of the output, that zero, the first, the maximum possible output which was there at zero, and you are printing the generated text, and it has written a poem. So three-step process. One, load the install the transformer, load the model, particular model, whether it is GPT or any other model that you want to load, give the input and generate the output. That's it. You can use any image based models as well. So there is a separate pipe module inside the uh, inside the Hugging Face called diffuser. So diffuser modules, y- you can import any model. So we are importing diffusion pipeline class, and using this class Using the instance of this class, you can download any model from the Hugging Face. So if you see here, in the three line of code, what we have done, so we first import. Okay, so you okay cancel. So I have to manage the session. So that okay. So let's close this. Close this. Okay. So once we import this diffuser pipeline module pipeline class, so you see this is in capital, so it is a class. So using the instantiation, we can create a pipeline, and using that we are from pre-trained all the model pre-trained model, you are importing stable diffusion model which is based on the diffusion concept, diffusion model base model it is there. Uska version 1 you are importing it, and once you import it, you have imported into, and you are referring it as a pipe. So it is it has done. So this, now you are importing. Once it is import from the Hugging Face, once it is load the model, this particular model from Hugging Face, you can use it. And that stable diffusion models, so diffusion based models are used to generate the images. And this particular model is stable diffusion model. What you does, you give a prompt and it will generate an image out of it. You might have seen in the Gemini or any other model that you give the right, okay, generate this image. You will see it is quite easy in the Python as well, the using Hugging Face. So once it will run, so that shows uh, the architecture of that whole model. You just give the prompt, and the pipe variable, you just pass the prompt, and it will generate the possible images that you have. And when you, so previous, okay, so this is running. Once it will stop running, you will see the output. So I had earlier I given a horse with the wing, and it has generated this image. See how beautiful and image that model has generated. So you can write the prompt and you can generate the image. So again, from Hugging Face, you can capture any model and you can use it for your purpose. So it is 3 or 4 line of code. And diffusion models are the latest computer vision models that generate realistic images with high resolution. So we have just loaded the model, and we have given the prompt and we have used it. That's it. So I think we can let's end this session here. All this Jupyter notebooks I will share it, including this LLM ones. And one announcement for you, that the quiz 2 will be uploaded today, uh, today night. So tonight we'll the quiz 2 will be uploaded, and quiz will remain open till tomorrow night 12 o'clock. So you have whole day from tonight to tomorrow night 12 p.m. 12 not 12. So due to time restrictions, I may not cover detailed uh, topics and detailed things in the session, but uh, I have given you starting points. You can use those starting points to work and to connect, to explore basically. uh, if I come again tomorrow or day after tomorrow, I'll give you a demonstration of how you can build your own chatbot in Python using Olama framework with minimum code. So you can use any LLM, and you can have your own LLM on your system, and that also required uh, minimum amount of coding. So that's it for today's session. Thank you. Do we have other quiz? So, Miss Quiz 2. Quiz 2 is there. Uh, okay, so I'm sending all those so information, all those notebooks, so that it will be uploaded today in the canvas, so you can check.